In tonight's video, we'll continue our peaceful journey through our solar system with a slow, relaxing walk in starlight, while I keep you company as you gently drift off to sleep. So, get comfortable, settle in, and let yourself unwind. If you're new here, welcome. And if you're returning, welcome home. It's always a pleasure to have you here. If you enjoy relaxing space journeys like this, feel free to subscribe so you don't miss future adventures. Now, if my voice helps you relax, you can close your eyes whenever you're ready. There's nothing you need to do, nowhere you need to be. Just breathe slowly, let your thoughts fade, and enjoy the quiet. Tonight, we'll visit all 8 planets of our solar system, one by one, taking our time as we travel through the vastness of space. So, get cozy, relax, and let's begin our journey among the stars. Mercury, the scorched messenger. We begin our long, silent passage outward at the very edge of the solar furnace, where light is blinding and space itself feels heavy with energy. Here, resting in the immediate embrace of our sun, lies Mercury, the nearest world to the solar star. It is a small, compact sphere of ancient rock, a solitary wanderer that has spent billions of years dancing on the absolute brink of fire and darkness. Because it sits so close to the immense gravitational pull of the sun, Mercury moves through its orbital path with an incredible, sweeping speed. It flies across the void so fast that a single year there, one complete lap around the sun, lasts just 88 Earth days. It is the quickest traveler in our skies, a restless dot of stone catching the raw power of daylight. But while its journey around the sun is hurried, its rotation on its own axis is heavy, sluggish, and deeply strange. Mercury turns so slowly that its motion creates a beautiful, complex rhythm known as a 3-to-2 spin orbit resonance. This means that for every 2 times the planet completes its quick orbit around the sun, it rotates on its axis exactly 3 times. This precise geometric harmony produces a sky unlike any other world we know. If you could stand on its ancient, dusty ground at just the right longitudes, you would watch a celestial choreography that feels completely surreal. The sun would rise very slowly from the flat horizon, appearing small but intensely bright. As it climbs higher into the pitch-black sky, it would suddenly seem to halt its motion entirely. Then, it would quietly drift backward for a little while, retracing its steps, before pausing once more and continuing its forward journey toward the opposite horizon. It is a slow, looping dance written directly into the heavens, a silent rhythm dictated by pure gravity. Because of this slow turning, a single solar day, the time it takes for the sun to rise, set, and return to the same spot in the sky, lasts an astonishing 176 Earth days. On Mercury, a single day is twice as long as its entire year. It is a world where time stretches out, unhurried and heavy, balancing long epochs of blinding light against vast stretches of frozen shadow. Mercury is a world stripped down to its absolute essence. Unlike Earth, which is wrapped in a thick, protective blue blanket of air, Mercury possesses almost no atmosphere at all to cushion its rocky shell. It stands completely naked against the harsh environment of open space. Because there is no thick layer of air to store the sun's warmth during the day or to shield the ground from the freezing vacuum during the night, Mercury experiences a brutal, daily contrast that defies our earthly experience. When the sun shines directly down upon the gray stones at noon, the surface temperature scorches far above 400 degrees Celsius. It is a blistering heat hot enough to melt solid lead, turning the day side into a silent, shimmering furnace. But as the slow sun finally sets and the heavy darkness returns, there is no air to hold on to that heat. The warmth instantly radiates back out into the cold void, and the temperature plunges far below freezing, dropping to a bitter, frigid negative 180 degrees Celsius. Across this brutal span of time, the ground continuously cycles between blistering fire and absolute ice, a resilient stone surviving under the weight of severe geometry. When we look past this extreme climate, we find a surface that reads like a preserved archive of ancient time. Because Mercury has no wind to blow away the dust, no rain to wash away the soil, and no active water to smooth the landscape, its crust has remained almost completely unchanged for billions of years. The ground is entirely filled with countless craters, overlapping rings, and sharp, crisp rims that look as freshly etched as the day they were formed. It is a visual record of the early solar system's violent history, a quiet testament to the ancient bombardments that shaped the rocky inner worlds. When our robotic spacecraft Messenger entered Mercury's orbit in 2011, it began a historic 4-year mission that completely transformed how we perceive this tiny world. It peered beneath the harsh sunlight and mapped vast, smooth volcanic plains that filled older, giant basins billions of years ago. But it also discovered something completely unexpected: giant cliff-like wrinkles called lobate scarps that cross the crust for hundreds of kilometers. Some of these cliffs rise kilometers high into the dark sky, cutting right across older craters and smooth plains alike. These massive scars record a quiet, heavy geological story, a story of global contraction. You see, Mercury is a planet dominated by its interior. Unlike Earth, its massive iron core occupies a much larger fraction of its size, filling nearly 80% of the planet's radius. As this giant metallic heart slowly cooled over eons of time, the interior began to solidify and contract. As the core shrank, the outer rocky crust was forced to wrinkle and compress to accommodate the smaller size, causing the entire planet to shrink in radius by several kilometers. Mercury is a world that literally grew smaller as it aged, leaving its wrinkles written permanently into its stone. Messenger also revealed strange, bright, and shallow depressions called hollows. These irregular shapes look freshly etched into the crater floors, gleaming with a high reflectivity that suggests volatile materials are actively escaping from deep within the rock today, proving that even this small world is not entirely inert. And at the exact opposite side of the planet, directly across from the massive Calorus impact basin, Messenger imaged a jumbled, chaotic terrain. Here, fractured blocks of crust and tilted hills look as though they were violently shaken and tossed. Scientists believe that when a giant asteroid struck Mercury billions of years ago to create the 1,000-kilometer-wide Calorus Basin, the intense seismic shockwaves traveled completely through the body of the planet, focusing and meeting at the exact opposite side, shattering the landscape in a single moment of immense power. Let your thoughts wander across these ancient, wrinkled plains as we prepare to drift deeper into the secrets of this scorched traveler, moving further away from that jumbled terrain of shattered crust. We follow the path of our robotic guides into the deepest, darkest secrets of this small world. One of the most astonishing discoveries made by our instruments challenges everything we expect from a world pressed so close to the solar fire. At Mercury's poles, there are ancient crater floors with towering rims that completely block out the sun's blistering path. Because of the planet's nearly vertical axial tilt, the rays of the sun can never reach inside these deep depressions. For billions of years, these regions have been locked in permanent shadow, acting as absolute, undisturbed freezers where temperatures remain frozen far below freezing in deep cosmic winter. And there, inside that absolute, eternal darkness, data solidified the case for the presence of frozen water ice. Scientists believe this ice was delivered to the planet long ago by traveling comets and asteroids that collided with the young world. The water vapor released from those impacts drifted across the vacuum, eventually settling in these cold traps where it froze solid and became permanently sealed away from the universe. Messenger even detected dark, organic material mixed with the ice, showing us that these remote shadows are repositories of ancient cosmic history. It is a striking poetic contrast. Blistering fire near noon on the plains, and frozen water sleeping in nighted pockets, right next to the solar furnace. Mercury also holds a surprise within its hidden core, generating a global magnetic field that is incredibly rare among small, rocky planets. While Venus and Mars lack this global protection, Mercury holds a shield, powered by a core that remains partially molten deep below. But this magnetic field carries a strange, beautiful asymmetry. It is offset slightly to the north, instead of sitting perfectly in the center of the planet. This unique offset shapes how the raw solar wind interacts with the surface, sweeping the magnetic shield backward into a miniature magnetosphere, with a long tail that flows like a quiet banner downwind. As the energetic particles of the solar wind pelt the exposed surface rock, they sputter and blast atoms directly out of the stone. These freed particles of sodium, potassium, and calcium form a near vacuum known as a ghostly exosphere, where atoms bounce around in ballistic hops without ever colliding with one another. When sunlight hits these floating sodium atoms, they glow faintly in the dark. This creates a magnificent, shimmering sodium tail that stretches away from the sun for millions of kilometers into deep space. A beautiful visual proof that this scorched world is not inert. If we look deep inside the planet, the structural story links its craggy crust directly to its massive heart. The oversized core is composed mostly of iron, and as it slowly cools over oons, it drives the continuous contraction recorded by the wrinkled cliffs on the surface. Scientists study multiple formation scenarios to explain why Mercury kept such an enormous metal core, considering early collisions that may have stripped away its outer rocky mantle. The geochemical data suggests a highly complex history, revealing unexpected elements like sulfur that force us to revise simple models of planetary birth, showing that proximity to the Sun does not erase structural complexity. The gentle advance of Mercury's orbit also served as the ultimate test for our understanding of gravity itself. For a long time, astronomers noticed that the closest point of its orbit to the Sun, the perihelion, advanced slightly faster than the traditional laws of physics predicted. This quiet puzzle was finally resolved by Albert Einstein, who showed that the immense mass of the Sun subtly curves the fabric of space-time around it. As Mercury loops through this warped space, its path shifts in a way that matches Einstein's general relativity with absolute mathematical elegance. This small effect turned the scorched traveler into a precise instrument for understanding the cosmic laws of the universe. From Earth, this quick world is often hard to see, washed out by the brilliant twilight of the morning and evening sky. But a few times every century, it passes directly across the blazing solar disk. During this elegant transit, observers with safe filters can see Mercury as a tiny, moving black dot gliding precisely across the Sun, a beautiful cosmic clock linking orbital paths to predictable time. Now, a joint mission called Bepi Colombo is on its route to this small world, preparing to separate twin spacecraft into coordinated orbits. With instruments that surpass all previous suites, it will refine our maps, measure chemical abundances, probe the glowing exospheres, and listen to the humming of the magnetic tail with higher fidelity. Science advances by these quiet, steady steps, narrowing our options and tightening our explanations with every refined number. For your memory, hold on to just a few peaceful anchors. A fast year, a slow day, a giant core, a shrinking shell, and ice sleeping in permanent darkness. Let the image of Mercury's gray highlands and shimmering sodium tail soften gently in your thoughts. As the silent world fades into a quiet mist, and we prepare to extend our unhurried journey outward toward the dense clouds of Venus. Venus, the greenhouse inferno, we leave the gray, shrinking crust of Mercury behind, drifting deeper into the dark, quiet velvet of space. Our slow passage carries us outward to Venus, a world that astronomers often call Earth's planetary twin. from the comfort of our home. When we look up at the twilight sky, Venus appears as one of the most beautiful sights in the heavens. It gleams with a pure, steady light, shining as the brilliant morning star and the evening beacon, a celestial jewel that has guided human eyes and inspired quiet myths across countless generations. It sits right beside us in the solar system, sharing almost the exact same size, the same mass, and the same rocky composition as our own planet. Yet, when we pierce through its deceptive outer glow, we find a world of complete and absolute contrast. A heavy, cautionary example of how small changes in air and chemistry can alter the destiny of an entire world forever. Venus is wrapped in an incredibly thick, heavy, and suffocating blanket of atmosphere. It is an air so dense that it behaves almost like a fluid, choking the landscape beneath it. This atmosphere is composed almost entirely of carbon dioxide. More than 96% of the entire globe is locked under this invisible weight. High above the ground, suspended in this thick air, lie permanent massive clouds made of toxic sulfuric acid. These acidic clouds never part. They wrap the entire planet in a seamless, unbroken mask that completely hides the surface from our telescopes. They reflect the distant sunlight with immense strength, which is the exact reason why Venus blazes so brightly in our night sky. But beneath that brilliant ceiling lies a trapped nightmare, a world of crushing pressure, endless sulfuric storms, and a constant, unyielding volcanic fire that never leaves the ground. If you could stand on the scorched, hidden ground of Venus, your body would experience a physical reality that is hard to imagine. The air pressure alone is 90 times greater than the atmospheric pressure on Earth. It is a crushing force equal to being nearly a kilometer deep beneath the waters of an ocean trench, heavy enough to flatten solid metal structures into complete silence. Because of this brutal environment, Venus has always been one of the most hostile and challenging planets for humanity to study. Every robotic explorer we have ever sent to its surface has traveled across the void only to survive for a few fleeting minutes. The Soviet Union sent a series of courageous Venera probes through the 1970s and 1980s, and their survival was measured in mere moments before the intense heat destroyed their delicate circuits and the heavy air flattened their metal hulls. Yet, in those brief windows of survival, they sent back a few iconic, precious images. They showed a dark, scorched ground littered with jagged rocks and flat, broken slabs of stone, all resting quietly under a heavy, permanent orange haze. The heat on Venus is a relentless, permanent presence, because the thick carbon dioxide air acts like an inescapable, global greenhouse. It locks the sun's energy in a continuous cycle. When sunlight manages to filter down through the dense acid clouds, it warms the rocky ground below. The surface then tries to radiate that energy back out into space as infrared light. But the carbon dioxide blocks it completely, absorbing the warmth and trapping it right against the crust. Venus holds its heat tightly, rather than letting it escape back into the cold void. This runaway greenhouse effect keeps the surface at a constant, blistering temperature of more than 460 degrees Celsius. It is a heat hot enough to melt solid lead, making the surface of Venus significantly hotter than Mercury. Even though Venus orbits nearly twice as far from the Sun, even during the immensely long night, or at the isolated poles where sunlight never hits directly, the blistering heat never fades away. Fierce, heavy global winds circle the planet continuously, redistributing the trapped warmth across the entire globe, ensuring that the entire world remains locked in a permanent, simmering fever that knows no season and no relief. Unlike Earth, which is protected by an invisible web of magnetic lines, Venus completely lacks a global magnetic field. Our home generates its vital magnetic shield deep within, through the constant, energetic churning of molten iron in its liquid outer core. This magnetic bubble deflects the harsh solar wind, preserving our atmosphere and protecting life across billions of years. Venus, however, seems to have a sluggish, slow-moving, or perhaps entirely solid core, which prevents the dynamic dynamo effect needed to weave a protective field. Without this magnetic net, the upper atmosphere of Venus stands completely exposed, constantly bombarded and eroded by the relentless stream of charged particles flowing from the Sun. Over vast eons of time, this solar wind has stripped away the lighter elements of the air, pulling hydrogen atoms out into the deep void of space. This permanent loss of hydrogen helps explain why Venus, a world that models suggest may have once started as Earth's equal, diverged into such a destructive path. It turned its ancient, shallow waters into vapor, leaving its oceans to dry up and vanish, transforming a potential oasis into a locked, global oven. Venus rotates on its axis with a heavy, deeply strange rhythm. Unlike most of the planets in our solar system, which spin in the same direction as the Sun's rotation, Venus turns backward. This rare phenomenon is known as retrograde rotation, a reverse spin that sets it apart from its peers. If you could look past the clouds and watch the sky from its surface, the Sun would rise very slowly in the west and set in the east. Its rotation is so incredibly sluggish that it takes 243 Earth days for the planet to complete just one single spin on its axis. Because its orbital journey around the Sun takes 225 Earth days, a single day from one sunrise to the next on Venus actually lasts longer than its entire planetary year. It is a world where time seems to slow down, stretching its days into vast, unhurried epochs. Yet, while the solid, heavy ground turns like a slow shadow below, the thick upper atmosphere behaves in a completely opposite manner, moving at supersonic speeds high above. This phenomenon, called superrotation, drives a permanent global gale that circles the entire planet in just 4 Earth days. These ferocious winds whip the acid droplets across the skies at hundreds of kilometers per hour, creating storms that never truly fade, while the heavy surface remains locked in darkness far below. This rapid movement gives Venus its striking, ghostly brilliance, a sight noticed by every ancient culture long before telescopes revealed its harsh, crushing nature. When we map this hidden terrain using specialized radar, it reveals a landscape entirely reshaped by intense internal heat. Unlike our home planet, Venus does not possess shifting tectonic plates. Instead, it holds a single solid rocky shell. Without moving plates to release internal pressure gradually, the heat builds up silently beneath the crust for hundreds of millions of years, trapped until it violently forces its way out in massive, planet-wide events. Vast floods of liquid lava have resurfaced wide areas of the planet, creating immense smooth plains and shield volcanoes larger than any found on Earth. The radar data also revealed strange, circular features called corona, which mark where massive plumes of hot mantle pressed upward from deep within, warping the crust into a dome before cooling and collapsing into wrinkled rings. These features exist nowhere else in the solar system in such grand numbers, because there is a profound lack of small impact craters across the globe. Planetary scientists believe the entire surface is geologically young, perhaps less than 1 billion years old, completely rewritten by widespread volcanism. This tells us that Venus is still active on vast geological timescales, a restless world sleeping under a blanket of volcanic history. In recent years, observations have brought Venus back into the absolute center of our curiosity. In the year 2020, a controversial detection of phosphine gas in the upper atmosphere was announced. Phosphine is a molecule that is incredibly difficult to explain without unusual chemistry, and some researchers even argued it might serve as a faint marker for microbial life floating high in the relatively temperate cloud layers. Though a later reanalysis challenged the signal, pointing out possible errors in data handling. the spirited debate continues among scientists. This intriguing episode renewed global interest in our mysterious twin, prompting agencies to plan a grand return to its skies. A fleet of sophisticated new missions is now on the way to pierce the veil once more. NASA's Veredas and Da Vinci Plus, alongside the European Space Agency's Envision mission, are each being equipped to probe the air, map the rocky terrain with unprecedented clarity, and test for active signs of volcanic eruptions. NASA's Da Vinci Plus will eventually plunge directly through the atmosphere, measuring the trace gases from top to bottom, while Veritas will create global radar maps to track any recent changes in the landscape. Envision will join them, adding detailed spectroscopic views and constant atmospheric monitoring. Together, these instruments will transform our knowledge, turning a blank, hazy sphere into a known and deeply explained world. Deep within the thick layers of these methane-rich and carbon-dense clouds, conditions may also be extreme enough to create something completely extraordinary: falling diamonds. Under the immense pressure and suffocating heat of the lower atmosphere, scientists believe that carbon atoms can break apart from their molecular chains and compress into perfect crystalline structures, creating tiny, glittering diamonds that rain down silently through the dark towards the heavy core. If this theory holds true, then storms of shimmering crystals are drifting through the deep, orange, tinted darkness of our sister world, a hidden spectacle of light trapped beneath a crushing ceiling of acid and ash. Without a protective magnetic dynamo, the planet continues to generate induced magnetic fields from currents running through its thick, ionized air. These offer a partial, weak shield against space radiation, but they remain highly unstable, leaving the landscape permanently exposed to the deep solar wind. This ongoing erosion explains why the lighter, life-giving elements have slowly vanished over the millennia, leaving behind only the heaviest gases to cook in the slow, simmering heat. Venus stands as a profound cautionary example, a beautiful morning star that hides an absolute inferno beneath its quiet, steady glow. It teaches us that planetary size and mass are not enough to guarantee a paradise, because the atmosphere is decisive, and a few small shifts in chemical balance can mean the difference between an oasis and total desolation. Scientists study these extremes with great care, because our own future is tied to the delicate balance of greenhouse gases, a quiet warning carried in every blurred image returned from the Venusian plains. Let the image of these heavy, golden clouds and toxic spires soften in your thoughts. Let the crushing pressure ease away as we lift our minds off the scorched, ancient stone. We are drifting slowly outward now, leaving the blazing oven of Venus behind, moving gently into the cool, dark space where a familiar blue beacon waits to welcome us home, Earth and the Moon. The living oasis. We glide smoothly through the silent darkness, watching the heavy, golden clouds of Venus fade away into the distance. As we drift further into the quiet void, the crushing heat begins to lift, replaced by a sight that feels instantly familiar, safe, and deeply comforting. A fragile blue sphere appears before us, wrapped in delicate, swirling wisps of white cloud, suspended perfectly against the dark velvet of space. This is Earth, the only world known to hold life, and the only planet we can ever truly call home. What makes this planet stand out among all the cold rock and barren gas worlds of the cosmos is its exquisite, fragile balance. Earth sits in the absolute heart of the Sun's habitable zone, a precise cosmic sweet spot where the daylight is steady enough and the warmth is gentle enough to let liquid oceans persist on the surface for billions of years. Vast, deep oceans cover more than 2/3 of our world, balancing the heavy air above with the liquid water below, regulating the global climate, and cradling a sprawling web of biology. The air we breathe is a delicate, active blend of nitrogen and oxygen, with just the right amount of trace greenhouse gases to keep our world from freezing into a solid ball of ice or scorching into a barren desert. Unlike its rigid planetary neighbors, Earth is a dynamic living machine. Beneath our feet, the solid rocky crust is broken into a network of massive plates that float slowly and silently across the semi-molten mantle. This intricate system of plate tectonics is completely unique to Earth. These moving plates quietly create earthquakes, build protective mountain ranges, and recycle carbon dioxide, beautifully regulating our global climate over vast geological eras. Volcanoes gently release life, renewing gases from deep within. Earthquakes mark the shifting boundaries of our continents, and every rock cycle works in complete harmony with the oceans and the atmosphere to sustain long-term habitability. While we watch our blue world spin slowly on its axis, we notice its permanent companion drifting silently in orbit beside it, the Moon. Compared to the size of its host planet, Earth's moon is unusually large. No other rocky planet in our solar system has such a relatively massive satellite. In fact, the moon is about 1/4 the diameter of Earth. Most scientists believe this close partnership began with a violent fire billions of years ago, when a Mars-sized body collided with the young Earth. The immense impact ejected a vast ring of molten debris into orbit, which gradually cooled and coalesced to form the solitary sphere we see tonight. This permanent companion plays a vital, quiet role in guiding the rhythm of our ecosystems. The gravitational pull of the moon creates our daily ocean tides, drawing water across massive basins, shaping coastal currents and mixing vital nutrients. Millions of years ago, these repeated cycles of wetting and drying in tidal pools may have encouraged early life to step from the sea onto the land. Even more importantly, the steady gravitational tug of the moon stabilizes Earth's axial tilt. Without the moon, our planet's axis would wander wildly over millions of years, causing climates to shift chaotically and creating environments too unstable for life to endure. In this way, the moon is not just a silent decoration in our night sky. It is a faithful partner that guards Earth's stability with a subtle, protective force. As we drift closer to the moon, the vibrant blue of Earth fades into a landscape of stark monochromatic beauty. Because the moon has no real atmosphere, no wind and no rain, its surface acts as an untouched, faithful geological archive of ancient time. The footprints left behind by human astronauts remain completely preserved in the fine gray dust, looking exactly as they did decades ago, unbothered by time. The lunar surface is divided into a beautiful contrast of terrain. We see bright, rugged highland regions scarred by ancient impacts, sitting right beside vast, dark basalt plains called maria. These maria were formed billions of years ago when violent asteroid impacts cracked the young lunar crust, allowing liquid lava from the interior to flood the deep basins and cool into smooth, dark plains. Because there is no active geology to erase the past, the craters on the moon remain perfectly intact, preserving a visual diary of every bombardment that has occurred since the earliest days of the solar system. The only force that slowly wears away this landscape is space weathering, a gentle, incredibly slow erosion caused by cosmic radiation and the constant impact of microscopic dust grains called micrometeorites. Samples of volcanic rocks and fragile glass beads brought back by human missions have revealed the deep chemical secrets of this barren world, helping us read the history of our own planet's birth. Though the bond between Earth and the moon seems timeless and unchanging, it is slowly evolving. The friction of the ocean tides gradually transfers rotational energy from Earth into the moon's orbit. Because of this subtle exchange, the moon is slowly moving away from us, drifting about 3.8 centimeters farther into space every single year. In the distant past, the moon was much closer, looming massive and dominant in our night sky. Billions of years from now, its orbit will grow so wide that total solar eclipses will no longer be possible. Yet, despite this gradual retreat, The Moon remains tightly locked to Earth by gravity. It takes the exact same amount of time for the Moon to spin once on its axis as it does to complete one orbit around our planet. Because of this perfect synchronous rotation, the Moon always shows the exact same face to Earth, leaving its heavily cratered far side forever hidden from our eyes on the ground. Orbiting spacecraft have revealed that hidden hemisphere, showing a rugged, mountainous landscape with almost no smooth dark plains, a strange asymmetry that continues to puzzle scientists today. Let your thoughts linger on this quiet, drifting partnership, a living world and a silent archive, locked in an elegant dance of gravity and time. Deep beneath the oceans and the drifting continents of our blue world lies a hidden heart that silently works to keep us safe. Earth's interior is built in beautiful, heavy layers, a thin rocky crust, a thick mantle of slowly moving silicates, and a massive core split into two distinct parts. At the very center sits a solid ball of iron, but surrounding it is a sea of liquid metal, swirling and churning continuously. This constant movement of molten iron generates an immense, invisible magnetic shield that extends far out into the open void. This magnetic field is one of Earth's most vital, protective features. It acts like an invisible net, deflecting the harsh solar wind and preventing the relentless stream of cosmic particles from stripping away our atmosphere. Without this unseen core beneath us, our air would have gradually leaked into space over billions of years, leaving the surface barren, frozen, and completely dry, much like what occurred on Mars when its own internal dynamo failed. Sometimes, a few of these solar particles manage to slip through the magnetic shield near the poles, colliding with the gases in our upper air. When they meet, they release energy in the form of shimmering curtains of green, red, and violet light, the auroras. They are a breathtaking spectacle in the polar night, a silent visual reminder of the invisible shield that guards our climate and our lives every single second. When seen from the quiet perch of orbit, Earth appears as a beautifully interconnected system. High above the atmosphere, weather satellites quietly circle our world, tracking the delicate balance of greenhouse gases, shifting ocean currents, and changing ice cover. Lately, these measurements have shown rapid shifts in our atmosphere. Rising levels of carbon dioxide and methane are trapping more infrared radiation, gradually warming the global average and altering ancient weather patterns. The very same principles of greenhouse physics that turned Venus into a locked furnace apply here as well, serving as a quiet warning that habitability is a delicate gift, one that requires constant balance and care. For the few human beings who have ever looked back at Earth from deep space, our planet ceases to be a collection of separate countries or distant continents. Astronauts often speak of a profound psychological shift known as the overview effect. Standing in the absolute silence of the void, looking at our home from afar, all human borders completely vanish. You see only a single, unified oosis, bright, fragile, and intensely alive against the backdrop of an endless, dark universe. Every memory, every culture, and every story we have ever told exists within that thin, glowing blue line of air. It is a sight that inspires a deep sense of unity and peace, reminding us how precious our small corner of the cosmos truly is. Now, human eyes are turning back toward our lunar companion with a renewed sense of wonder and purpose. Decades after the footprints of the Apollo missions were pressed into the gray dust, new plans are unfolding to return to the Moon through the Artemis program. This time, the goal is not just to visit, but to build a permanent presence, using the Moon as a natural stepping stone to the deeper frontiers of space. Robotic explorers are already mapping the polar craters, searching for large deposits of water ice locked away in the permanent shadows. This ancient ice will not only sustain human life, but can be broken down into hydrogen and oxygen to manufacture fuel for voyages to Mars and worlds far beyond. Standing on the silent ground of the moon, the night sky looks profoundly different than it does from Earth. With no atmosphere to scatter the daylight, the stars remain brilliantly visible even during the day. If you stood on the near side of the moon, Earth would hang steadily in the black heavens above the horizon, an unmoving, glorious globe 4 times larger than the moon we see from our backyards. You would watch the continents slowly rotate into view underneath swirling storms, a glowing blueprint of life drifting in the dark. Though the solar system is vast and filled with grand wonders, the Earth and the Moon remain our ultimate anchors, the cosmic reference point against which all other worlds are measured. When our advanced telescopes scan distant stars, hunting for alien exoplanets, they are searching for the faint chemical fingerprints of oxygen and liquid water, looking for a reflection of Earth. Every discovery we make abroad simply reflects back to us, deepening our appreciation for the rare, poetic architecture of our home. Let the image of this blue oasis and its faithful gray partner settle softly into your mind. Let your breathing match the slow, eternal rhythm of their orbits. We are leaving the safe embrace of Earth behind now, drifting further out into the cool, quiet desert of space, where the rusty plains of Mars wait in the silent starlight. Mars, the frozen frontier. We drift gently away from the protective blue shield of Earth, gliding deeper into the vast, quiet corridor of the inner solar system. Our slow, unhurried passage carries us toward a smaller world, a cold, silent desert gleaming with a distinct ochre light against the dark velvet of space. This is Mars, the red planet. For centuries, this rusty world has captured human imagination more than almost any other celestial body, inspiring generations of astronomers to gaze through early telescopes, wondering if alien canals crossed its rugged terrain and if ancient civilizations built cities across its dusty plains. But the modern spacecraft we have sent across the void have revealed a much colder, quieter, and deeply sobering truth. Mars is a frontier of absolute silence, a place frozen in time, yet it holds profound secrets and mysterious puzzles that keep us searching for the faint fingerprints of past life. Mars is a world stripped of its ancient warmth, sitting as a quiet transition between the rocky inner planets and the immense gas giants that lie ahead. The atmosphere here is incredibly thin and fragile, composed almost entirely of carbon dioxide, making up less than 1% of the atmospheric pressure we feel on Earth. Because this blanket of air is so thin, it lacks the weight and the structure to store the sun's gentle warmth. As soon as daylight fades from the landscape, the heat escapes instantly back into the open void of space, causing the temperature to plunge into severe, bitter cold. Under this light ceiling of air, a liquid water cannot remain stable on the surface. It instantly evaporates into thin vapor or freezes solid into deep subterranean ice. Yet, despite its thin air, Mars is not a completely motionless world. It experiences colossal, planet-wide dust storms that can engulf the entire globe for weeks or even months at a time, completely blocking out the distant sun and reshaping the dusty canvas of the landscape. These massive storms are driven by solar heating, as fine particles of iron-rich dust are lifted high into the sky, wrapping the entire planet in a permanent, hazy reddish glow. It is a rusty, restless desert where the wind whispers across ancient stones, carrying memories of a very different past. When we look beneath this hazy red sky, the geography of Mars reveals features of an absolutely mind-boggling scale. Standing silently in the northern plains sits Olympus Mons, the largest volcano in the entire solar system. It towers nearly 22 kilometers above the surrounding landscape, rising almost 3 times the height of Mount Everest into the thin Martian night. It is a giant shield volcano so immensely wide that if you placed it on Earth, it would completely cover an entire sprawling territory. Its slopes are exceptionally gentle, built up slowly over eons of time by countless individual layers of liquid lava flowing from a single volcanic hotspot. On Earth, our shifting tectonic plates move across the mantle, creating chains of smaller volcanic islands like Hawaii as the crust passes over a heat source. But Mars completely lacks active plate tectonics. Its crust is a single, rigid, and stationary shell, because the ground remains perfectly still. The magma from deep within was able to erupt through the exact same spot in the crust over millions of years, building a single, colossal monument of stone that looms quietly in the cold Martian night. Near this giant sit the Tharsis Plateaus, holding an entire family of other colossal, extinct volcanoes that prove Mars once held a fiercely hot and energetic interior, feeding grand eruptions billions of years ago. As we move away from these volcanic giants, the crust of Mars splits open into a magnificent, echoing chasm called Valles Marineris, the grandest canyon system in the known universe. It stretches for more than 4,000 kilometers across the Martian equator, a distance so vast it would span the entire width of a major continent from coast to coast. In places, this immense canyon plunges over 7 kilometers deep, making it more than 5 times deeper than the Grand Canyon on Earth. Its towering walls are carved with massive landslides, deep ridges, and ancient geological layers that expose the planet's internal history to the vacuum of space. While Earth's canyons are typically carved slowly by the relentless flow of liquid rivers, scientists believe Valles Marineris opened as a massive structural fracture billions of years ago, as the nearby Tharsis Plateau swelled with volcanic magma. Its immense weight pulled the crust apart, cracking the surface of the planet open in a single era of immense geological stress. Walking through such an endless expanse would mean standing before cliffs that stretch past the horizon, watching long shadows fall across silent valleys that were sculpted by immense cosmic forces, now permanently frozen in time. But the most captivating story Mars tells is written in its dry river valleys and ancient, sweeping deltas. When we look from orbit, we see clear, unmistakable evidence that liquid water once flowed abundantly across this landscape. Advanced rovers have explored the bottoms of ancient crater lakes, like Jezero Crater, discovering minerals like clays and sulfates that can only form in the presence of liquid water. They have studied layers of sediment shaped by ancient, rushing streams that emptied into wide lakes billions of years ago. The pattern across the entire planet is beautiful and consistent. Billions of years ago, Mars was a wetter, warmer, and geologically active world, a place where rivers could run and lakes could rest under a much thicker atmosphere. But as its internal core cooled and its protective magnetic shield faded away, the solar wind stripped the air apart, transforming a promising cradle of water into the frozen, quiet desert we see today. Let the image of these massive, silent canyons and rusty volcanic peaks soften in your thoughts. Let your mind drift quietly across the peaceful, dusty plains of the red planet. Today, the remaining water on Mars exists mostly in a solid state, permanently locked away in the vast polar ice caps. These frozen poles are made of a beautiful, layered mixture of water ice and frozen carbon dioxide, commonly known as dry ice, which expand and contract dynamically with the changing Martian seasons. Deep beneath the rusty, windswept soil, massive sheets of pure water ice lie buried, shielded from the vacuum of space by layers of dust. In certain areas, scientists have observed strange, dark streaks appearing on steep hillsides during the warmest months of the Martian year, features known as recurring slope lineae. While their exact origin is still heavily debated, some researchers believe they could be caused by thin films of salty water, or brines, seeping briefly out of the ground before evaporating away into the thin air. Whether these streaks are dry dust flows or liquid brines, the confirmed presence of massive underground ice keeps the tantalizing question of past or present habitability wide open. Another captivating mystery that continues to puzzle planetary scientists is the periodic detection of methane gas in the fragile Martian air. Methane is an unstable molecule that is quickly broken apart by solar radiation, meaning that any methane found today must have been released by a very recent source on or beneath the surface. Robotic explorers, like the Curiosity rover inside Gale Crater, have measured fluctuating levels of this gas that rise and fall unexpectedly with the seasons. If this methane is being released by deep underground volcanic activity or chemical reactions between warm water and rock, it proves that the interior of Mars is still alive in some subtle way. But if that gas is being produced by ancient, deep-dwelling microscopic organisms, the discovery would reshape our understanding of biology forever. For now, the signal remains a haunting, beautiful mystery, drifting through the thin red air. High above the quiet desert plains, Mars hosts two tiny, misshapen companions dancing in the dark sky, Phobos and Deimos. These miniature moons look vastly different from Earth's large, luminous satellite. They are irregular, heavily cratered, and look more like stray asteroids caught in a permanent gravitational trap. Many scientists believe they were originally part of the nearby asteroid belt, drifting through space until the immense gravity of Mars gently snared them into orbit long ago. Phobos, the larger of the two, orbits incredibly close to the planet, rushing across the sky multiple times a day. Because it is so close, tidal forces are gradually pulling it inward, and millions of years from now, it will either crash into the rusty crust or break apart into a beautiful, temporary ring around the planet. Deimos, on the other hand, stays much further away, drifting slowly against the backdrop of distant stars like a quiet, fading memory. Humanity has explored this silent frontier through a legendary lineage of robotic emissaries. Tireless rovers like Spirit, Opportunity, Curiosity, and Perseverance have completely transformed how we look at the red planet. Spirit climbed rugged hills, while Opportunity crossed vast plains for 15 years, sending back thousands of images before a massive, global dust storm choked its solar panels in darkness forever. Curiosity continues to drill into ancient lake beds, while Perseverance actively explores the deep sediments of an ancient river delta, carefully catching precious samples of rock and soil into small metal tubes. One day, a grand future mission will return these wayward stones to Earth, allowing scientists to analyze them with the most precise instruments humanity has ever built, searching for the absolute chemical proof of ancient life. High above these mechanical wanderers, orbiters like the Mars Reconnaissance Orbiter and the Mavivan spacecraft monitor the planet day and night, tracking the evolving landscape from space. Their cameras capture towering dust devils twisting silently across the orange plains, white frost forming on the rocks at dawn, and thin, wispy ice clouds drifting gracefully over the summits of giant volcanoes. Mavivan specifically measures how the upper atmosphere slowly leaks into space, proving that without a global magnetic field to protect the air, the intense solar wind has spent billions of years eroding the atmosphere away, stripping a once warm, blue world into a silent, frozen desert. Mars stands as both a profound hope and a quiet caution for humanity. It shows us how fragile a planet's balance can be, and how easily a world can slip into decline when its internal protective systems fail. While Earth remains a brilliant, successful oasis, Mars is a frozen monument to what could have been. Yet the dream of sending human pioneers to walk across these rusty deserts continues to grow, driving us to develop advanced propulsion systems, deep space habitats, and closed-loop life support technologies that will one day carry our species across the great void. If humans one day stand on the red plains of Mars, looking up to see Earth as a tiny, fragile blue dot shining in the twilight sky, it will rival the deepest perspectives we have ever gained. Let the image of these drifting rovers, silent ice caps, and chaotic moons soften gently in your thoughts. Let your mind rest in the absolute silence of the Martian night. We are leaving the inner, rocky worlds behind now, drifting past the final desert of stone, and preparing to cross the immense, empty spaces ahead, where the Vishal, sovereign king of the solar system, waits in the deep blue dark. Jupiter, the sovereign giant. We leave the quiet, rusty plains of Mars behind, gliding smoothly across the immense, empty spaces of the asteroid belt where ancient building blocks of stone drift in silent, lonely orbits. As we travel further into the outer domains of the solar system, the light of the sun grows faint and distant, replaced by the towering presence of a world whose sheer scale defines the entire system. This is Jupiter, the sovereign king of planets. It is a colossal, majestic gas giant so visual that its immense mass is more than twice that of all the other planets, moons, asteroids, and comets combined. For billions of years, this visual world has acted as both a protector and a powerful governor of our cosmic neighborhood, using its immense gravitational pull to steer wandering asteroids, deflect traveling comets, and anchor the stable paths of the inner worlds. To study Jupiter is to understand the giant's deep influence, a world whose history is permanently tied to the survival of Earth itself. Jupiter is a planet completely stripped of a solid surface, a world made entirely of shifting gas, liquid, and immense cosmic energy. Its outer atmosphere is a visceral, turbulent ocean composed mostly of hydrogen and helium, beautifully layered with delicate clouds of ammonia, methane, and water ice. When we look at this giant through our telescopes, we see a magnificent canvas of alternating colorful bands stretching across its visible disk. These pastel-colored zones and dark belts are sculpted by complex atmospheric chemistry and intense thermal energies rising from deep within the interior. Each band represents a powerful jet stream moving in opposite directions at hundreds of kilometers per hour, carving the upper clouds into a restless, swirling masterpiece. Trapped within these turbulent belts sits the most famous feature in the solar system, the Great Red Spot. It is a visual, counter-clockwise rotating vortex of clouds wider than Earth itself, a colossal storm that has been raging furiously across the southern hemisphere for at least 300 years. The wind speeds along its outer edges exceed 400 kilometers per hour, and its high cloud tops tower far above the surrounding atmospheric layers. While the storms on our home planet are measured in short days or weeks, this Jovian tempest is a permanent monument to the planet's deep energy, its reddish hues continuously fueled by complex chemical reactions triggered by high-altitude compounds and sunlight. It is a living laboratory of physics, a giant storm system interacting with smaller ovals and dark barges in a grand planetary dance that never rests. If we lift our eyes off the colorful clouds and peer deep into the interior, Jupiter reveals a structural story built on unimaginable pressure. As you travel deeper into the thick atmosphere, the weight of the gas above increases exponentially, crushing the hydrogen molecules together until they transcend the boundaries of gas and liquid. Thousands of kilometers below the cloud tops, the pressure becomes so extreme that it forces electrons to detach from their atoms, transforming the hydrogen into a dense, glowing ocean of liquid metallic hydrogen. In this exotic metallic state, electricity flows freely through the churning liquid, generating an immense global magnetic field that is stronger than any other planet in the known universe. This visual magnetosphere extends for millions of kilometers into space, forming an invisible magnetic bubble so grand that if it were visible in our night sky, it would appear larger than the sun itself. It envelopes the planet's dozens of moons and rings, capturing charged particles from the solar wind and forming intense radiation belts of high-energy plasma. This trapped radiation is incredibly lethal, strong enough to fry the unprotected electronics of visiting spacecraft within hours, forcing our robotic explorers to shield themselves behind thick armor and follow careful, Diving orbital paths. At the very center of this metallic ocean lies Jupiter's core, a region that was long thought to be a compact sphere of solid, heavy rock. But advanced gravity measurements sent back by the Juno spacecraft have revealed a much more mysterious, unexpected reality. The data suggests that Jupiter holds a diluted, fuzzy core that is spread out across a visceral region instead of being a sharp, solid ball. Scientists believe this fuzzy core is a structural scar left behind by a giant impact early in the solar system's history, when a planet-sized body collided with the young giant, mixing its heavy metallic center with the surrounding fluid layers. Even the visual king of planets carries the memory of early violence hidden beneath its serene, banded clouds. Let the image of these swirling colorful bands, powerful jet streams, and the ancient crimson storm soften gently in your thoughts. Let your mind drift quietly across the visual, whispering layers of the king of planets. Surrounding this visual gas world is a sprawling family of satellites that acts like a miniature solar system of its own. While Jupiter hosts over 90 moons bound by its immense gravity, the 4 largest Galilean satellites stand out as some of the most remarkable worlds in the cosmos. First observed by Galileo Galilei in the year 1610, these distinct worlds form a laboratory of intense planetary physics powered by gravity and magnetism. The closest of these 4 giants is Io, a seething, restless world covered in active volcanoes. It holds the title of the most volcanic body in the entire solar system. Its surface constantly rewritten by massive eruptions of molten sulfur and rock that paint the landscape in vivid tones of yellow, red, and black. Some of its furious volcanic plumes rise hundreds of kilometers directly into the cold vacuum of space. This intense activity is driven by tidal heating. As Io completes its quick orbit, it is continually squeezed and stretched by the immense gravitational pull of Jupiter, alongside rhythmic gravitational tugs from its sibling moons. The friction from this constant structural flexing heats Io's interior to a molten state, fueling an unmatched geological engine that continuously feeds plasma into Jupiter's magnetosphere. Moving slightly outward, we find Europa, a silent world of cracked ice that has become a central target for astrobiology. Europa hides a vast, global ocean of liquid water beneath its frozen shell. The surface is crisscrossed with a beautiful network of dark lines and ridges, showing where the ice shell constantly fractures, shifts, and slides over the water below. Kept warm by the same engine of tidal heating, this hidden sea is estimated to be incredibly deep, potentially holding more liquid water than all of Earth's oceans combined. Spacecraft have detected magnetic signatures and faint water plumes erupting from the surface cracks into the void, suggesting that hydrothermal vents may exist on the dark ocean floor. If these warm vents touch a rocky core, they could provide the heat, minerals, and chemical energies needed for alien life to flourish in the deep dark. The upcoming Europa Clipper mission will soon fly close to map this frozen crust and test its habitability. Beyond Europa drifts Ganymede, the largest moon in the entire solar system. It is a massive body larger than the planet Mercury, wrapped in a crust of ancient scarred ice and grooved terrain that records an active geological past. Ganymede is entirely unique because it is the only moon known to generate its own internal magnetic field. This field interacts dynamically with Jupiter's visual magnetosphere, creating shimmering auroras in its thin atmosphere. Scientists believe that Ganymede also hides multiple layers of liquid oceans, sandwiched between massive sheets of ice deep within its heavy structure. Despite its immense scale and planetary complexity, it remains bound inside the giant's magnetic grasp. The final Galilean moon is Callisto, a silent relic of the ancient solar system. Callisto holds one of the oldest, most heavily cratered surfaces in the cosmos, its landscape scarred by over 4 billion years of continuous impacts. Unlike its dynamic siblings, Callista shows no major signs of internal heating or surface renewal, serving as a quiet witness to the early history of planetary formation. Yet, even beneath this ancient, frozen crust of ice and dust, magnetic measurements hint at a dark subsurface ocean kept liquid by salts and pressure. It reminds us that even the most quiet, cratered worlds can hide secrets sealed beneath layers of ice and time. These 4 dynamic moons are locked in a precise gravitational resonance that pumps energy into their structures, keeping their interiors active far beyond what their size suggests. The electric currents running between Io and Jupiter's poles create intense auroras that glow constantly in ultraviolet light. To explore this visual domain, our modern spacecraft must dive quickly through the giant's radiation belts, utilizing hardened armor to harvest data before systems degrade. Jupiter stands as a visual template for gas giants across the universe. By studying its turbulent bands, its fading crimson storm, and its miniature solar system of moons, we build the models used to interpret the light of distant exoplanets orbiting alien stars. Every pass made by our explorers narrows our questions and deepens the grand story of our system. Let the image of these 4 distinct moons, of fire, ice, magnetism, and ancient memory, settle softly into your thoughts. Let your mind rest as we prepare to drift further into the outer dark, where the magnificent, ringed elegance of Saturn waits in the quiet starlight. Saturn, the ringed elegance. We leave the intense radiation and the visual, turbulent bands of Jupiter behind, drifting deeper into the cold, silent realms of the outer solar system. Our unhurried passage carries us across vast stretches of empty space toward a world that has captivated human eyes for centuries, a planet wrapped in unmatched elegance and cosmic order. This is Saturn, the ringed giant. From the comfort of our home, even through a small telescope, the first sight of this pale yellow world is a moment that is completely unforgettable. It stands suspended against the dark velvet of space, surrounded by a magnificent, glowing structure of icy bands that shine by reflecting the distant sunlight like a sheet of frozen light. For astronomy itself, Saturn has always been a supreme symbol of beauty and balance, a visual gas world where gravity has sculpted the smallest grains of dust into a masterpiece of cosmic choreography. The majestic rings that make Saturn famous are an incredibly vast yet astonishingly delicate structure. They stretch out across hundreds of thousands of kilometers, spanning a width that dwarfs the size of major planets. Yet in most places, they are paper, thin, measuring less than 100 meters thick. If you could turn the planet sideways, this visual sheet of glass would nearly disappear from view entirely. The rings are composed almost entirely of pure water ice, mixed with small traces of rocky dust and dark organic material. Far from being a solid, continuous track, this shimmering spectacle is made of billions of individual icy particles, ranging in size from microscopic grains of dust to house-sized boulders, each circling the giant at its own speed in a perfect orbital balance. Continuous, gentle collisions among these fragments constantly reshape the fine patterns, creating a living system of cosmic waves. When we observe the rings closely, we notice sharp edges, empty lanes, and narrow gaps that split the icy sheets into distinct bands. These gaps are not empty by accident. They are shaped by the subtle gravitational influence of tiny moons that orbit directly within or just outside the ring zone. Moons like Pan and Daphne's act as dedicated shepherds, using their gentle gravity to hold the ring edges in place, clearing out empty lanes like the Encke and Keeler gaps. As these tiny shepherd moons glide through the icy material, their gravity pulls on the nearby fragments, creating beautiful, vertical ripples and fine wave structures along the edges of the gaps that look like delicate ripples on a glassy pond. The legendary Cassini spacecraft spent over a decade orbiting this giant, capturing these fine details in sharp clarity, and proving that the rings are actively interacting with the satellites in a constant feedback loop. Saturn itself is another massive gas giant, composed mostly of primordial hydrogen and helium gas layered over a heavy internal core. But what makes Saturn entirely unique among the outer worlds is its exceptionally low density. It possesses an average density that is actually lower than that of liquid water. This means that if you could somehow find an ocean vast enough to hold it, the entire planet of Saturn would float gently on the surface like a ball of cork. Because of this light, diffuse structure and its exceptionally rapid rotation, the planet flattens noticeably at its poles while bulging outward at its equator, a gentle distortion that is clearly visible from orbit. The atmosphere of Saturn is wrapped in subtle, pastel bands of gold, tan, and soft brown, producing a more muted appearance than the vivid crimson belts of Jupiter. These quiet tones are created by layers of ammonia, methane, and hydrogen hazes reacting under the weak light of a distant sun. Yet, beneath this serene, elegant mask, the climate is ever changing and driven by immense internal energies. The winds on Saturn are faster than almost any other world, reaching breathtaking speeds of up to 1,800 kilometers per hour through the upper air. Periodically, deep convection forces massive storms to erupt from the interior, releasing latent heat and wrapping around the entire planet in visual bands that can persist for months before slowly fading into memory. At the planet's frozen North Pole sits one of the most surreal phenomena in the solar system, the hexagon. First revealed by the Voyager probes and later mapped in deep detail by Cassini, it is a nearly perfect, six-sided jet stream swirling endlessly around the pole. This geometric atmospheric wave spans over 30,000 kilometers across, a structure wider than Earth itself that has remained stable for decades. The fact that such a perfect, straight-edged geometric shape can emerge naturally from the fluid motion of a spinning atmosphere continues to fascinate scientists, revealing the deep, elegant physics that governs the restless skies of this ringed giant. Let the image of these paper-thin icy rings, dancing shepherd moons, and the silent geometric storm at the pole soften gently in your thoughts. Let your mind drift quietly through the pastel golds and shimmering ice of this elegant world. Saturn, the ringed elegance, part toward, surrounded by these majestic bands of ice, drifts a vast and sprawling system of satellites, transforming Saturn's orbit into a complex miniature solar system. Among its many dozens of confirmed moons, two unique worlds stand out as prime targets for modern science, offering environments that challenge our very understanding of habitability. The largest of these companions is Titan, a massive moon that stands as the second largest in the entire solar system. Titan is completely unique among all planetary moons because it possesses a dense, thick atmosphere rich in nitrogen, laced with methane and complex organic compounds. This choking air forms a permanent, heavy orange haze that completely hides its solid surface from human eyes. But when specialized radar managed to pierce through this thick veil, it revealed a landscape sculpted by a deeply familiar yet completely alien hydrology. Titan is the only other place in the known universe that holds stable liquids on its open surface. However, under a distant sun, it is far too cold for liquid water to exist. Instead, Titan's vast lakes, flowing rivers, and smooth seas are made of liquid methane and liquid ethane. Methane clouds drift across the thick skies, dropping methane rain that carves deep drainage channels through dark dunes made of hydrocarbon sand. It is a world with familiar coastlines, rivers, and seasonal storms built from entirely alien substances, an absolute twin to Earth's own water cycle. Deep beneath this frozen landscape of organic chemistry, scientists believe a vast subsurface ocean of liquid water may also lie silently hidden. In the year 2005, the small Huygens probe detached from Cassini and descended directly through the orange air, transmitting historic images of icy river rocks and muddy plains of organic runoff before falling silent. In the future, the innovative Dragonfly mission will return to Titan, using a rotorcraft to fly gracefully across its hazy skies, testing the prebiotic chemistry of its sands to expand our understanding of how life might emerge in distant worlds. Sailing in a tighter orbit drifts a much smaller companion that became one of the greatest surprises of modern exploration, Enceladus. It is a tiny, brilliant ball of pure water ice reflecting nearly all the sunlight that strikes it. But despite its small size, Enceladus hides a spectacular cosmic secret. From deep fractures near its south pole known as tiger stripes, towering geysers blast massive plumes of water vapor and ice crystals directly into the open vacuum of space. These spectacular plumes are continuously powered by tidal heating, as the intense gravitational tug of Saturn flexes the Moon's interior, generating the thermal energy needed to keep a global subsurface ocean from freezing solid. The Cassini spacecraft flew directly through these erupting plumes multiple times, sampling the fresh spray and detecting salts, complex organic compounds, and direct evidence of active hydrothermal vents on the dark ocean floor. On Earth, similar underwater volcanic vents support sprawling ecosystems in the absolute dark without ever needing a single ray of sunlight. If the same hydrothermal chemistry is active within Enceladus, its hidden sea could hold all the vital ingredients required for life, making this tiny icy moon one of the most promising frontiers in the search for biology beyond our home. Other moons in this vast system hold their own unique character, from tiny Mimas, which bears a giant impact crater that makes it resemble a fictional space station, to hyper-reflective Iapetus with its stark two-toned surface of dark dust and bright ice. These distinct satellites continuously exchange material with the rings, creating a living network of gravity where the boundaries between moon and dust are constantly blurred. Though the rings of Saturn appear timeless and permanent to our eyes, the data returned by our explorers tells a much more fleeting story. The Cassini mission revealed that the rings are young by planetary standards, perhaps less than 100 million years old, born from the remnants of an ancient shattered moon pulled apart by gravity. Today, they are gradually disappearing. Drawn in by the giant's magnetic field and intense gravity, streams of ice particles are continuously draining inward in a process known as ring rain. This shimmering spectacle is a temporary feature in the solar system, a fleeting phase that will eventually fade completely back into memory over the next few 100 million years. At the end of its historic 13-year orbit, when its fuel was nearly exhausted, the Cassini spacecraft was commanded to execute a dramatic grand finale. It dived repeatedly through the narrow, unguided gap between Saturn and its innermost rings, sampling the native fields and gases before plunging directly into the crushing atmosphere of the planet itself. This final destructive plunge was deliberately chosen to protect the pristine oceans of Titan and Enceladus, ensuring that no earthly microbes could ever contaminate these delicate, hidden cradles of potential life. Saturn stands in the deep outer sky as an image of supreme cosmic grace, a world that teaches us how complexity and breathtaking beauty emerge naturally under the quiet laws of gravity. Let the image of these melting rings, liquid methane seas, and towering water geysers soften gently in your thoughts. Let your breath carry you further outward into the deep cosmic cold. We are leaving the golden elegance of Saturn behind, drifting slowly into the silent, uncharted darkness where the tilted, pale green sphere of Uranus rolls along its lonely path. Uranus, the tilted ice giant. Part 1. We leave the fading, golden elegance of Saturn behind, drifting into the deep, quiet dark of the outer solar system where the warmth of the sun is little more than a distant, brilliant pinprick of light. Our slow, unhurried passage carries us across vast, lonely expanses of space toward a world that breaks almost every rule of planetary motion. This is Uranus, the first planet discovered in the modern era using a telescope, found quietly gliding through the stars by William Herschel in the late 18th century. Unlike the heavy gas giants we have left behind, this distant world belongs to a distinct class of planets known as the ice giants. It is a sphere wrapped in a pale, serene cyan haze, standing as a tranquil, frozen monument to the extreme variations that gravity and early cosmic collisions can inflict upon a world. The most defining, extraordinary characteristic of Uranus is its extreme orbital tilt. While most planets in our solar system spin almost upright, like spinning tops gliding across a flat table, Uranus rolls along its path completely on its side. Its rotational axis is tilted by an astonishing 98 degrees. Scientists believe this unique, radical orientation was caused by a colossal cataclysm billions of years ago, during the chaotic early days of planetary formation. A planet-sized body, perhaps twice the mass of Earth, may have violently struck the young world, knocking it completely on its side and permanently disrupting its rotational rhythm. Because it rolls sideways through its long 84-year journey around the Sun, Uranus experiences the most extreme and prolonged seasons in the solar system. For decades at a time, one pole faces the distant Sun directly, bathed in continuous, weak daylight, while the opposite pole is turned away, locked in a freezing, pitch-black winter that lasts for a human generation. When we look through the calm, featureless exterior of this pale green world, the atmosphere reveals a delicate chemical blend that creates its unique color. The upper air is composed mostly of hydrogen and helium, but it contains a higher concentration of methane gas than its larger neighbors. Methane possesses a specific molecular structure that absorbs the longer, red wavelengths of the incoming sunlight, while reflecting the shorter blue and green light back out into the open void. This simple atmospheric filtering is the exact reason why Uranus appears as a smooth, pristine ball of pale turquoise hanging in the absolute dark. It is a quiet, deceptive mask that hides a fiercely cold and complex interior beneath its calm, unmoving facade. Uranus holds the title of the absolute coldest planetary atmosphere in the solar system, with temperatures plunging far below freezing, dropping to nearly negative 224 degrees Celsius. Unlike Jupiter and Saturn, which radiate massive amounts of internal heat left over from their birth, Uranus releases almost no internal energy into space. Its interior has cooled drastically over eons, or perhaps the massive ancient impact that knocked it on its side also served to vent its primordial warmth out into the void, leaving it a quiet, shivering giant. Yet, despite this profound lack of heat, the upper atmosphere is still driven by subtle, deep winds that can reach speeds of up to 900 kilometers per hour. Because the planet rotates quickly on its side, completing a single spin in just over 17 hours, these high-speed winds form long, faint clouds that stretch parallel to its equator, visible only through the eyes of advanced space telescopes and the lonely visitor Voyager 2. If we journey past these cold, methane clouds into the hidden depths, Uranus reveals a structure that separates it completely from the gas giants. It does not possess a vast, deep ocean of liquid metallic hydrogen. Instead, beneath its outer envelope of air lies a massive, dense mantle composed of hot, high-pressure water, ammonia, and methane ice. Planetary scientists often refer to this exotic region as a fluid, slushy ocean of water, ammonia volatiles, an electrical soup where the immense crushing pressure forces molecules into unique states that defy our traditional concepts of solid ice. This churning, high-density fluid ocean acts as the planet's internal engine, generating a highly unusual global magnetic field. Unlike Earth's field, which sits neatly aligned with our planet's center, The magnetic field of Uranus is tilted by 60 degrees relative to its rotational axis and is offset completely from the planet's geometric core. As the sideways planet spins, its unbalanced magnetic lines wobble and twist chaotically through space, creating a complex, shifting barrier against the solar wind that resets every single day. Let the image of this pale green sphere, rolling silently on its side through the freezing dark, soften gently in your thoughts. Let your mind rest in the tranquil, unhurried pace of this distant ice giant. Uranus, the tilted ice giant, Part 2. Surrounding this pale green sphere drifts a delicate system of rings that looks vastly different from the bright, icy bands of Saturn. The rings of Uranus are incredibly dark and narrow, composed of 13 distinct bands made of charcoal-like material and large rocky fragments. These dark structures were discovered unexpectedly in the late 20th century, when astronomers watched Uranus pass in front of a distant star, noticing the starlight blink out multiple times before and after the planet itself blocked the view. Scientists believe these rings are geologically young, formed from the remnants of ancient, small moons that were shattered by violent impacts or pulled apart by the planet's relentless gravity. Two tiny moons, Cordelia and Ophelia, act as dedicated shepherd satellites for the brightest outer band, using their gentle gravity to keep the dark fragments tightly locked within a narrow track, preventing them from bleeding away into the open void. Beyond these dark rings, Uranus hosts a diverse family of 27 moons, all named after famous characters from classical literature. Among these satellites, 5 major worlds stand out for their complex landscapes of ice and stone. The most spectacular and chaotic of these is Miranda, a small moon with a surface that looks like a jumbled puzzle piece. Miranda features giant canyons, parallel grooves, and towering cliffs that plunge 12 kilometers deep into the vacuum. It looks as though it was violently shattered into pieces multiple times by immense impacts during its early history, only for the fragments to pull back together haphazardly under the slow, weak draw of gravity, creating a chaotic masterpiece of geological disruption. The larger moons, like Ariel and Umbriel, Titania and Oberon, show their own unique personalities locked in ice. Ariel features smooth valley floors carved by ancient fluid flows, while Umbriel remains dark and heavily cratered, a quiet world that has seen very little internal change since its formation. Titania, the largest of the family, is cut by massive fault lines and valleys that stretch for hundreds of kilometers, proving that its interior once expanded as it froze, cracking the outer shell open. These distant moons are completely locked to Uranus by gravity, always showing the exact same face to their sideways master as they circle its tilted equator like a bullseye in the dark sky. Our structural understanding of this distant ice giant relies almost entirely on a single, fleeting encounter in human history. In January of the year 1986, NASA's Voyager 2 spacecraft screamed past Uranus, becoming the first and only human emissary to view the planet from close range. In just a few intense hours, Voyager 2 captured thousands of images of the pale cyan atmosphere, discovered 10 new hidden moons, revealed the complex offset magnetic field, and mapped the fractured valleys of Miranda. Since that historic flyby, no other spacecraft has returned to its skies, leaving Uranus a peaceful, lonely world monitored only by the distant eyes of the Hubble Space Telescope and the James Webb Space Telescope. Planetary scientists are actively advocating for a dedicated return to this mysterious world, designing sophisticated flagship missions that would place an orbiter into its system and drop an atmospheric probe directly into its cold clouds. This future probe would measure the trace gases from top to bottom, determining the exact chemical abundance of noble gases and checking if the core is truly solid or diluted. By mapping the gravitational fields with precision, we can unlock the deep structural history of how ice giants form Expanding our models for the thousands of similar worlds, we now detect orbiting distant stars across the galaxy. Let the image of these narrow charcoal rings, jumbled ice cliffs, and the lonely legacy of our robotic guide soften gently in your thoughts. Let your breathing match the slow, steady rhythm of this rolling giant. We are leaving the turquoise tranquility of Uranus behind, drifting across the final, freezing threshold of the major planets, where the deep blue, windswept majesty of Neptune waits in the outer dark. Neptune, the windswept majesty. We leave the pale, rolling sphere of Uranus behind, drifting across the final, freezing threshold of the major planetary system. Our slow, unhurried passage carries us into the deepest, coldest domains of the solar system, where the sun appears as nothing more than a brilliant star yielding little to no warmth. Here, suspended in the absolute dark, lies Neptune, the eighth and outermost major planet from the solar star, discovered in the mid-19th century not by random observation, but through the absolute elegance of mathematics. Astronomers noticed that the orbit of Uranus was being subtly pulled by an unseen gravitational anchor. By calculating the precise location of this disruptive force, telescopes were pointed into the dark, revealing a world wrapped in a deep, majestic azure blue. It stands as a powerful, chilling monument to the outermost frontier, a giant world of water ice and supersonic winds that never rest. Neptune is an ice giant that shares a similar internal mass and structural composition with its twin, Uranus, yet it possesses a remarkably different character. While Uranus is calm, quiet, and featureless, Neptune is dynamic, energetic, and constantly changing. The vibrant blue color of its atmosphere is created by the presence of methane gas in the upper air, which absorbs the red wavelengths of light and reflects a deep, oceanic blue back into the dark void. But because Neptune possesses a slightly higher concentration of heavier elements and hazes, its blue is far more intense and vivid than the pale cyan of its neighbor. It is a stunning, deep sapphire marble hanging in the blackness of space, a majestic world where the atmosphere is driven by an internal heat source that remains a profound puzzle to science. Unlike Uranus, which releases almost no internal warmth, Neptune radiates more than twice the energy it receives from the distant sun. Deep within its interior, radioactive decay and the heat left over from its violent birth continue to churn and rise toward the surface. This internal heat engine drives the most violent weather in the solar system. The winds on Neptune are absolutely legendary, reaching breathtaking speeds of over 2,000 kilometers per hour, twice the speed of sound and faster than the winds of any other planet, including Jupiter. These supersonic gales rip through the methane air, carving the upper clouds into powerful jet streams that circle the globe in opposite directions, creating white high-altitude clouds of pure methane ice that cast distinct, moving shadows on the blue decks below. When NASA's Voyager 2 spacecraft flew past Neptune in August of the year 1989, it revealed a massive atmospheric feature that shocked the scientific community, the Great Dark Spot. It was a colossal, dark blue oval storm system nestled in the southern hemisphere, wide enough to swallow the entire planet Earth. It represented a massive, counter-clockwise vortex spinning relentlessly through the azure clouds, flanked by high-speed white cloud fragments nicknamed the Scooter. But unlike Jupiter's permanent Great Red Spot, Neptune's storms are strangely fleeting. When the Hubble Space Telescope looked back at Neptune just a few years later, the Great Dark Spot had vanished entirely, only for new dark spots to emerge and fade over different latitudes, proving that the giant's atmosphere is a restless, shifting ocean of gas that continuously rewrites its patterns over short years. If we venture beneath these tempestuous azure clouds, Neptune reveals a deep structure that mirrors its twin but carries its own immense pressure. Beneath its outer envelope of hydrogen, helium, and methane air, lies a vast, dense mantle composed of super-pressurized water, ammonia, and methane ice. This fluid, slushy ocean experiences a crushing weight that forces molecules to behave in extraordinary ways. In the deepest layers of this mantle, scientists believe the intense pressure breaks methane molecules apart, freeing carbon atoms that compress together into perfect crystalline structures, creating a continuous rain of tiny diamonds that drift silently through the hot fluid toward a solid, heavy core of rock and metal. It is a stunning, hidden spectacle, storms of diamonds falling through the deep dark of an icy empire. Let the image of these supersonic azure winds, shifting dark storms, and falling diamond rains soften gently in your thoughts. Let your mind rest in the vast, peaceful isolation of this outermost giant. Surrounding this deep sapphire giant drifts a system of 5 dark, narrow rings that are highly unusual. Unlike the neat, continuous bands of Saturn, the outer rings of Neptune possess thick, clumped regions where the material bunches together into bright, distinct arcs. Named Liberty, Equality, and Fraternity, these unique arcs have puzzled astronomers because the laws of gravity should cause the icy fragments to spread out evenly over time. Scientists discovered that Neptune's small nearby moon, Galatea, acts as a gravitational anchor, using its subtle orbital resonance to coral the dark dust and keep it trapped within these specific sections. These dark rings are continuously shifting, showing that the structures are geologically young and dynamically tied to the evolution of the inner moons. Beyond these delicate ring arcs orbits the crown jewel of Neptune's satellite family, a Triton. Triton is a massive, spectacular moon that stands as one of the most unique worlds in the entire solar system. It is the only large moon in the cosmos that orbits its planet in a direction opposite to the planet's own spin, a phenomenon known as a retrograde orbit. Because of this reverse path, scientists know that Triton could not have formed out of the original disk of gas that birthed Neptune. Instead, Triton was once an independent, frozen world traveling through the outer dark, until it drifted too close to the giant billions of years ago and was caught in a permanent gravitational trap. When Voyager 2 captured close-up images of Triton, it revealed a landscape of striking alien activity. The moon's surface is intensely cold, covered in a smooth crust of frozen nitrogen and water ice that resembles the wrinkled skin of a cantaloupe melon. But despite temperatures hovering near absolute zero, Triton is geologically alive. It features massive cryovolcanoes and ice geysers that blast columns of dark nitrogen gas and dust 8 kilometers directly into the thin, freezing vacuum. These dark plumes are instantly caught by Triton's faint winds, stretching for over 100 kilometers across the icy plains and leaving long black streaks on the pristine nitrogen snow. It is a stunning, quiet world where volcanic activity is driven not by molten rock, but by liquid nitrogen and volatile ices expanding beneath a frozen crust. Because Triton orbits Neptune in a retrograde direction, tidal forces are gradually slowing the moon down and pulling its path closer to the planet every single year. In the distant future, millions of years from now, Triton will drift past the safety threshold of gravity and be violently ripped apart by Neptune's intense tidal forces. The remnants of this shattered frozen world will spread out evenly across the equator, creating a massive, bright ring system that will rival the elegance of Saturn, turning the azure giant into a ringed masterpiece of the outer solar system. Our direct, close-up data for this windswept giant relies on that single, historic encounter by Voyager 2 in the late 20th century. As the spacecraft zipped past the planet and looked back across millions of miles, it captured a final, breathtaking view of Neptune and Triton appearing as 2 elegant, crescent shapes fading together into the vast cosmic dark. Since that summer day, no other robotic explorer has visited this distant realm, leaving Neptune a peaceful, lonely outpost monitored only by advanced telescopes orbiting Earth. With the completion of this outermost sapphire giant, our unhurried tour of the major planetary system draws to a quiet, natural close. We have traveled from the blistering, wrinkled rocks of Mercury, through the suffocating fires of Venus, past our protective blue Isis, across the rusty deserts of Mars, and through the colossal, majestic domains of the gas and ice giants. Each world stands as a unique monument to the laws of physics and gravity, to a diverse tapestry of environments woven from the same primordial cloud of dust and light. Let the image of these supersonic blue winds, erupting nitrogen geysers, and dark ring arcs soften completely in your thoughts. Let your breathing match the slow, eternal rhythm of these distant, drifting worlds. We are lifting our minds off the freezing azure clouds now, leaving the majestic kingdom of Neptune behind, and letting ourselves drift peacefully back through the cool, quiet space toward the safe, warm embrace of our home.